So we're looking for this guy right here, and as we can see, he is half a box coming in and out. So that's exactly what we want. That's gonna cause some major problems with our physics, and we will know that we are good to go when we can actually not have major problems with our physics when that happens. Let's make sure everything's saved properly, just to double check. And then we'll do a resolve in Perforce and snag all our changes as checked out files. Import process isn't perfect, but it's good enough for what we do. And that didn't actually import, so that's what I thought was going to happen. It's like that didn't feel like it actually saved properly. And this is again like the import thing can be kind of finicky. Just because when we disconnect from source control, it tries to save, but it's like, oh, the file was not writable, and then it silently fails on you. It's kind of a gigantic pain in the butt. But, well, some things you just gotta work around. So we can just reconcile all that work. Yeah, there's all our modified files, which is everything. So just make sure we got everything we need, and that looks absolutely correct. So if we run our physics, we should definitely be getting a few of these callbacks. Yeah, and as we can see immediately, we're getting some of them, and we're getting them again. And if we do like show collision, well, it looks like we'd have to zoom in a little bit closer. So let's go ahead and change our camera so we are actually zoomed in a bit closer, because we're going to need to look closer at these things. Perforce, why you gotta be a real pain in the ass all the time? You're busting my balls here, Perforce. So it's kind of a slow start, we're getting into it, but this is what it takes with coding. It's kind of slow, and then everything works all at once. Poor balls. Yeah, Perforce is a master at mashing things that are sensitive and causing all sorts of trouble. It's kind of like version control is, I think, the best saying I ever heard was version control is either a small pain in the ass all the time, or a gigantic pain in the ass some of the time. And stuff like Git is usually it's not a pain in the ass all the time. But then when it does explode on you, or explodes on somebody else in your project, it can be a gigantic mess. Perforce usually is not a gigantic mess, unless you do something completely stupid. but it is a constant pain in your butt. But it's a small one. It's like a little sliver that you can't quite get out. You're not really sure where it is, but you know it's there. You're like, you bastard. And other things are more likely, I would say, especially on game projects where you're dealing with large code and asset files. And, well, not to be a pain in the ass, but artists or non-engineers, you end up with a lot more problems. So as you can see when we're moving around, oh shit, our character is, when we do show collision, we are actually colliding with all of our things properly. Yeah, and as you can see here, like, we were able to move into this object. And that's what we need to make. We need to make it so we can move out nicely. And right now, we can't move when we're actually, because I'm trying to move out of it immediately, but we're getting stuck inside of it because of the animation. So we need to make it so basically we do not transition to the next animation. Because like we should be hitting our head, right? Then we don't. So yeah, and then we hit her. Then we stub our toe into it. So let us see if this works. Basically, this should just work if we, inside of our movement object, just do an overlap check. So we're gonna want to check if this component is a physics component. So let's see if we have the actual physics type. Yeah, so we need the physics object type. Get object type for code, so get object type for physics component. So yeah, it's going to be, we're going to pass in the component. So basically, we also want to do like if self equals null pointer or comp equals null pointer, then we're just going to return false. Otherwise, we're called back to check for overlapping. So let's get object type for physics component, and we are going to get our object type. So if the type, equals the physics object type, and we're looking for physics only, because hitboxes we don't care; those are fine to overlap with the world. So if the type equals e.g. physics, then we're going to do an overlap check. And how we're going to do that is just overlap component, or we should use our movement utils. Do we have a thing for a specific component in here? We just have like overlap object. And it's just called an overlap component with a thing on it, so we actually want to do the overlap ourselves. That's what it looks like. So I'm going to throw some of this movement stuff over in my other window. So we're just doing so we do need our position, so we're just gonna f vector position equals get position. And we're gonna call this one. And our overlaps are going to be here. So position, component, overlaps. The overlap is going to be this one, but it doesn't matter. Basically, we just return true. Yes, we did collide with the world. And let's print it out. So info log, we collided with the world when we try to change our physics state. And what that should do is we should move into the wall, and then we don't actually animate that physics box. We'll just stay unanimated. And we should have other side effects too, like if we start running up or down a hill, we're going to have the same exact thing where we can't actually change our physics box. And we just want to make sure it actually works. Yeah, this needs to return false. Get object type for physics component is a member of physics utils. Nothing crazy. So it's a lot easier to actually get things working when you've got your foot in the door on everything doing what it's supposed to. If you've noticed, the kind of the speed of development has picked up since, it took us a week to kind of get to, just basic ray casting working. And that was really just figuring out like what exactly the Unreal 4 ray casting sweeping system returns to us, and finding that like a lot of things we had to watch out for, like if you put your object at the end of your sweep, then you might actually be embedded in an object, so you had to pull yourself back a little bit and all sorts of stuff like that. I'm just going to shut down the editor properly so that the menu doesn't keep popping up. Good to see. It's not a 71-hour stream already. It's got more than that. If you check out the YouTube channel, right, we're up to like episode 80. Though I guess maybe not all of those are exactly 1 hour long. Some of them are less. Yeah, we're up to episode 80 on the YouTubes for this thing. So, trace tag dash. Alright, so as you can see, we are not getting stuck. We're getting stuck, like, we're not getting stuck inside of this object, so I can always move out of it. So it's exactly what we want. And we're snapping over into it when it disappears. Good. So let's go take a look at kind of how this works on a slope. As we expected on slope, we've got issues where our object stays that small little box. But we just want to make sure that everything kind of looks and works as it should. That we're not doing anything absolutely insane. That's looking pretty good. Shit. Okay, so we got that portion on there. Now we need to do the rotation part of this. So because right now, like, we should actually be turning to the left and stuff like that. Yes, you're correct. So let's see, we are going to want to add, I believe, a set direction. Do we have a direction for like velocity and all that stuff? Like our moving object has quite a bit of these things. So it's set wanted velocity. Got our Dashkin direction. Except look for declaration. Okay, so it's just E-Dashkin direction. So we're gonna need a thing here. It's basically gonna say void set direction. So we're going to have a couple set directions. We're going to have set direction in terms of like actually setting the direction. We're going to have like set direction by y, and then we're going to have like set direction by velocity with like a f vector. And this is just going to like call set direction by y on the velocity vector. Velocity dot y, and this will of course just call like if y is less than 0, then set direction left. Also if y is greater than 0, set direction dd right. And this one's gonna say like if like m direction equals direction and return, otherwise m direction equals direction. And we're also going to need a get direction and all that stuff. Get facing direction would be a better. Screw it, just get direction. Say return m direction. Call the set direction by y. Call to set direction by velocity. So all of our characters should start off facing to the right as well, I believe. So m direction needs to be dd right. We don't already have a direction. Okay, good. you never know, I sometimes half implement this crap beforehand and then I catch up to myself later. So we've got a direction. So basically we're going to say, like, if the direction is left, and if the direction's DD none, we're just not going to do anything. We're going to have like the angle. So this is going to be, the angle is going to be 0. So angle is, I really have no recollection of what the angle should be. So let's see, I believe I set it down here. In move object, when, you know, back when we had Fat Sack flying around in the air. I believe it was right here. So like this is going to the left is -90 and going to the right is the other one. So we're kind of doing that. Doing a thing. And then of course we need to add these functions to our class, and let's have them be public. Throw them up with kind of our set position and velocity stuff. So the question would be, where should we actually be setting our direction? And of course, I believe the question would be, how do we want the character to turn? And I think our turning should not always be based off of it should be based off of our wanted velocity. So whenever we call like wanted velocity, it should do something. What's up, Lucas? Why are you crying? Why y'all sad? Did I miss something? Oh man, well, I mean, I guess you'll just have to keep waiting, but it'll be there. Is Adam still streaming? He's like 1 in the morning now. Thank you for hosting, Karakan. We'll get everybody watching. Everyone. Where's Adam? Adam's finally offline. He just ended. Nice. Hopefully he's doing well in Hollow Knight, doing all the fun things. All the millions of followers, exactly. So let's see, is get direction? Yeah, we didn't declare that variable. I mean that function, so I'll do that. So we're gonna change our angle based on that. It should work. Thank you for hosting, Lucas. So we've got our angle set, and that should turn us, and we should now have horrible problems with our physics. And I believe we do also need to change our direction based on our wanted velocity. So we want these like wanted velocities to actually call all the things. So it's like set wanted velocity. I believe these are the two places that we should actually be setting it. So why don't we do that? And maybe we should just call like set direction auto, and that'll just take our wanted velocity and do it that way. So it's like, okay, after you set your wanted velocity, you'll just discover which way it should want to go. Hollow Knight. It became not fun. What? Well, you're just getting tired. You're getting tired, Adam. You're pushing yourself too hard. You're being a tryhard instead of... Nah, yeah, platformers, things can get really frustrating, so that's how it is. Call to set the direction to our wanted velocity direction. Tired and angry? Yeah. I have not played Hyper Light Drifter. Maybe I'll have to play that sometime. Gotta make it. Alright, Karakan, thanks for sticking around and being positive as always. Being helpful. So we are going to set our direction by our velocity, which is going to be our unwanted velocity. So theoretically now, Fat Sack's going to turn left and turn right, and that's going to just completely destroy what we're trying to do with physics. He'll get stuck in the wall and all that crap. So good, let's go get him stuck in the wall, and then we'll get him unstuck. Mostly positive. Well, more positive than others. Tired and angry. Tired and angry. Yeah. Well, at least you're not playing Battle Brothers and losing all your damn dudes just to some bullshit archer in the back row who just somehow cannot miss. At least your little Hollow Knight character doesn't get his head fucking ripped off every 3 seconds. You're just like, oh god, why? Now he's brain damaged. Why is he brain damaged? Ugh, fucking orcs. They're the worst. It works though. So for everybody here, we're basically trying to get our physics stuff to the next level. Our first stab at physics there had Fat Sacks doing. Yes, he had Fat Sacks. He's got an S now at the end of his name. So Fat Sacks was running around the platforms, but his physics box was not changing. Like, he is literally just a box man, and that's not what we want, right? Like, we want people who are dynamic. So if you take a look here, we've got it so every so often here, Fat Sack it's showing the hit and the physics box, but the physics box is actually the box on the left. So he's made of 2 boxes, and we are turning in the wrong direction. So I need to fix that. So, Oregon. So yeah, I'll pull it up real quick. Basically, with Fat Sack, I changed his physics box so that on frame 20 it becomes half width. And what that we already fixed it, so now he can like run into the wall and it won't freak out. It won't push him out of the wall. And we're not trying to do that. We're just trying to make sure that if we have a weird collision state, that it doesn't freak out our physics engine. We can still move properly. And right now that worked properly. I could run into the wall and then I could run out of it real nice and everything. And that worked great. So now what we're doing is we're getting it so he can turn left and right, and he won't like embed his butt into the wall and then get stuck in the wall forever. And right now that should be happening, so we're gonna go make sure that we can get our butt stuck in the wall. It's important to make sure that that happens. And then that way when we actually implement the code to fix it, that our butt doesn't get stuck in the wall, then we know we fixed the butts and walls problem. So it's a pretty bad problem with fat sacks. Alright, so we're running down. So this is what we're talking about. We can move right in there, no problem. But when we turn around, we're stuck forever. We can't get out. And if I turned around, if I turn, this way, I'm still good. So if I had a velocity to the left here, I could get out, but I can't. Can't actually get a velocity to the left. So, excellent. That's what we want to see. And how we're going to fix that is we're basically going to flip our direction, and then we're going to check our sub-physics, our physics components on our object, see if any of them are stuck, and if any of them are stuck, we're going to flip their transforms to the other direction. So what we want to do here is when we change our direction, so mcached components, we're going to have to go through all of them. And the thing is, we're gonna need to check then every frame to try to fix it. So we're not gonna flip the physics object on our guy. But we're gonna have to remember which physics objects we weren't able to flip, and then we're gonna need to go flip them. So I need to pull up a primitive component. So supposedly these with a primitive component, they have geometry and they have a transform, supposedly. I think it's like scene components. Yeah, scene component has a transform, so alright, transform. So we want component to world, the current transform of the component relative to the world. We just want the transform though. Yeah, well, basically what should be working tomorrow is we should be able to turn left and right as our characters and not get stuck in the train. And if we get incredibly lucky and everything goes well, we should also have multiple things running around. So if everything goes absolutely perfectly today, we'll have like a fat sack running around, and then you can like go interact with him. And as another fat sack, you could like go over and like jump off of him, stuff like that. It would work. So that's what we're trying to get to today. I do not understand why get component transform and get component to world are the same damn function. Okay, so we want get relative transform, and basically we want to see if the relative transform has any rotation component to it. So I think that's the key that we need to get this working. So F transform, local tran, and the local tran is going to be comp get relative transform. And so the relative transform should be a 0. So there's two cases here. The case is we are going from left to right and the component was already stuck. And the other one is we're going from left to right and the component was not stuck and is going to be stuck. Alright, why don't we just write it? There are three situations. One, the component was already stuck before the transform. We need to flip it back around. Two, the component was not stuck but will be stuck. Now we need to flip it back around. Three, the component was not stuck and will not be stuck. We need to do nothing. Well, the component was not stuck, but wasn't oriented properly. Alright, so basically we need to check if we need to actually do something about this. So, well, we could just check. Who cares? All right. So, yes. Good night, Adam. Good night. Quick, now that Adam's gone, we can talk shit about him. He sucks at Hollow Knight, doesn't he? No. I haven't watched his Hollow Knight stream. I've been busy actually sleeping since usually when he's at that point in the night, I am asleep. Maybe we should have like a kind of a contest there. I should start playing Hollow Knight and see if I beat it faster than he does. Just to mess with him. Then he'll get even more pissed off. Like, you bastard. Or maybe he beats me. And then I have to go transport salt around in Battle Brothers and bitch about it. Alright, where were we? I was going to get the callback working properly. So is overlapping the world, is got stuff that we want. Basically, we're just doing our overlap here. So we've got our position. Now, the other question that we need to answer is if we're using our scene transform properly inside of our physics tests. So why don't we go take a look at that real quick, because we should be using the scene components transform for the tests. And if we're not using that, then we're going to have some hits, some misses that we shouldn't get. So it's going to be movement utils, getting our component. We're doing physics utils overlap component S. So it's going to be our physics utils overlap component S. So we're calling shape get owner get transform. So this might be wrong. We might need to be. Can we get the transform directly on the primitive component? Yeah, so I think it's get component to world is what we need to call on all of these. Is that correct? Let's see. If we did shape, get component to world, dot get rotation. Okay, so we need to actually be calling that, I think. So why don't we just try that real quick? Because if we're not, yeah, I don't think we're doing it right now. We're not taking the child components rotation into account, which now matters. This is not shape, this is primitive. I don't want to do it in selection. Why do you always change the selection? Nobody likes that. Who thought that was a good idea? It's like in Microsoft Outlook, why is Control F forward? Why is that forward? In every other damn program, that's fine. And the answer is like Bill Gates or something. It's like, no, it should be forward. It's like, sir, but everyone else thinks it should be fine. You're just like, fuck you, I have mine. It's like, well, okay, sir. So position, component, overlaps. Position, component, overlap. So if we collide, we need to change ourselves. Basically, our rotator is going to be the opposite. We need to know the angle here. So if the angle, yeah, we'll just have like inverse angle. Where do we need that? We actually need to invert from whatever it is. So can we actually get that? Just like get relative transform. Yeah, so we already have local tran. So local tran dot get rotation dot get the y-axis. Set rotation is based on the rotator. Well, let's just print it off and see what it's giving us. The rotation of the child component is... I'm not super familiar with how Unreal 4's transform stuff works, so we will see. This rotation is it's a rotator? Or what is it? God damn, fucking IntelliSense. It's easier to just look crap up online. The rotation is an F quad. Local rot. So the quad is going to be X, Y, Z, and W. Get axis X? No, we don't want to get the axis. We want to... I guess just print out the XYZW? Or get the F rotator? Yeah, let's get the F rotator. rotator. That's just going to be the local rod.get rotator. It's just rotator. Okay. And what does this rotator have on it? My rotator has pitch, roll, and yaw, so let's just print those out. And I think it's roll is what we're looking at. Let's just do pitch, roll, yaw. Yeah. This child object is now colliding with the world. Otherwise, this child object is not colliding with the world. So, just throw an info log here. We are turning to angle. Let's just make sure to verify that we have all the correct information, that we're still colliding properly and all that stuff, because we know how to get this to work. We just need to make sure that we have the right information first, so we don't go do a whole bunch of work for no damn reason at all and then have to delete it all, because that happens all the time. Pitch roll, yeah. Alright, so we should have this. Because we're going to need another thing. We're going to need to check basically every frame to see if we can flip these things around to the right orientation for the children. And we're going to probably want to shortcut that so we're not trying every frame and going and grabbing rotation data when we don't need to. So it's going to be like dirty components, things like that. So let's take a look. We should basically, when we switch directions, it should say that, yeah, we're not, it's negative 90, 90, not colliding with the world. So we go in here and we turn to the left. Okay, so yes, the child object is now colliding with the world, so we do have the correct information. Excellent. Crap, but what was our pitch on roll? I didn't look at that. I did too quickly. So I'm still waking up, obviously. Ah, crap. We got ourselves stuck. I should have known better. Alright, so it was all zeros, which is as it should be. So this is a relative transform. So basically what we're saying is this should always be a 0 in the roll if it's correct. So that's all we have to do, is we have to check if the local rotator's roll is equal to the parent's roll, basically. Still trying to stay away, doing art helps. Stay awake, I guess, is what you meant to say. So, if we overlap, then what we want to do is we want to say the local rotator dot roll equals, I guess it doesn't really matter if it's going to equal 90 either way, I believe. Which just flips us around. Well, right is negative 90, left is 90. Should it be 180? Because it's, yeah, it should be 180, shouldn't it? So we'll just set our roll to 180. And we'll do another sanity check here just to double, just to make sure that we moved ourselves out. This child object is colliding with the world. Is still colliding with the world, otherwise child object is now not colliding with the world. And we actually need to set the transform here. So it's basically like, is there a set transform? Like, what do? We do like set actor transform? Is there like set component transform? I mean, there's a transform updated. But that's like a delegate, which is not what we want. So I need to figure out how to set the damn thing, because it should be on the scene component. So I mean, if we go to scene component.cpp, like, we should be able to just look for like transform, you know, something like that. Thank you for following, Demicus. Think I know who you are. Think I know who you are. Welcome. We are right now working on doing some physics stuff. Basically, our character at the moment is this box, and basically the center of the box is right there, and we've got it so basically the center is right here and this box is over on the side. So we switch directions, like the box will switch to, you know, the other side. So if we are like up against, you know, a wall and our center is over here, when we switch directions, our butt gets stuck in the wall. So what we're doing is we're just basically fixing that situation by introducing some really nice hacks. Basically, we're just not going to change where our physics box is, even though we've changed directions. And that's basically because we're going to guarantee that our objects are always symmetrical, but if there's like mathematical problems, we won't change where our thing is, because vector math is kind of screwed up in Unreal. And I'm not going to absolutely enforce that everything is perfectly symmetrical, so it'll work for almost every single case that we've got in our entire game. But it should be good to go once we actually figure out exactly what we're doing. So we're trying to figure out how to set the transform of a child component. That's the plan, at least. Thank you, Solo Techno, for following. Very much appreciated. So, primitive component, get component transform. So do we not have a get component transform inside of the scene component? Is that, according to the docs, that's where it exists. It's in scene component. Let's take a look at scene component.h to see exactly what it's doing. So a scene component is an actor component. I mean, is there a get component transform here? Yeah, so it's just getting the component to world transform. So is there a place where... Yeah, there's a probably deprecate this. Okay, that makes sense. So if this is like all sorts of screwed up, like Unreal's not finished touching this, this might be fun. We'll see if we can actually get anything decent here or not. So let's see. Should render is in here. Calc new component to world. Okay, so there is a calc new component to world thing here. So basically, we want to see where this is called, I believe. Because we want to change our new relative transform. We want to call this, but this is a protected method, so who can even call this? I mean, do we have to call something like... I mean, there's update component to world with parent, and we pass in parent socket. Jesus Christ. All this other crap. Relative rotation quad. Set relative location and rotation. I mean, that looks like what we want. I mean, it's got a sweep test in there? That's... And this is a public method, so I guess it's set relative location and rotation is what we're trying to do. Okay, so it's set relative location and rotation is what it looks like. Is what we've got to do in order to actually do this. So we got a couple options. It looks like it's built in that it'll do stuff like trying to move and like sweep. So I guess it's meant for like if you got somebody's arm and you're like, okay, try to set it at 90 degrees. And it's actually going to try to go there as opposed to actually going there. Which makes sense. But I believe, let's double check. It's got this out sweep hit test result. If we like set it to null and we set our teleport type to none, does this method actually just do what we want without any bunch of crazy crap? So we're calling move component. So let's see. Move component implementation. So if out hit is not null, we're going to set our hit result to something. Otherwise, conditional update component to world. Internal set